On a clear night, far from city lights, a faint, shimmering band stretches across the sky, the Milky Way. This glowing arc has inspired wonder and curiosity for as long as humans have gazed upward, its beauty both mysterious and inviting. For centuries, people believed this glowing river was the entire universe. Ancient cultures wove myths and legends around it, imagining it as a celestial pathway or the spilled milk of the gods. Today, we know it's our home galaxy, a vast city of hundreds of billions of stars and planets, all bound by gravity. Each point of light is a sun, many with their own worlds, making the Milky Way a place of endless possibility. The Milky Way is just one member of the local group, a cluster of over 50 galaxies, itself part of the Virgo supercluster, and ultimately a thread in the immense Laniakea supercluster. Our galaxy is just a single node in a vast cosmic network. Our place in this cosmic web is humbling, a reminder that we're a tiny part of a much grander universe. From our small vantage point, we can only glimpse the scale and complexity of the cosmos. What we see is only a fraction of the Milky Way's true nature. Much of its structure is hidden from view, veiled by dust and distance. The stars and nebulae make up just 10% of its mass. These brilliant objects are only the visible tip of a much larger galactic iceberg. The rest is dark matter, an invisible substance forming a massive halo that holds the galaxy together. Though we cannot see it, its gravitational pull shapes the Milky Way's fate. Without dark matter, the stars would drift away into intergalactic space. It acts as a cosmic glue, keeping the galaxy's spiral arms intact. The Milky Way appears as a band because we're inside its flat, rotating disk, looking edge-on through dense concentrations of stars and dust. Our perspective from within gives us a unique view of our galactic home. Our solar system sits about 26,000 light-years from the galactic center, giving us a unique inside-out view. We orbit quietly in one of the galaxy's spiral arms, far from the crowded core. Imagine being inside a giant frisbee. Look along the plane and you see a bright, crowded line. Look up or down, and the stars thin out, revealing the true shape of our galaxy. That's the Milky Way, a cosmic selfie from within. We are both observers and participants in this grand structure. Our galaxy is a dynamic, evolving structure, shaped by forces both visible and unseen. Stars are born, live, and die, while the galaxy itself drifts through space, changing over billions of years. As we explore further, we'll uncover the secrets of our galactic home and our place within it. Each discovery brings us closer to understanding the universe and our origins. The journey begins here, on a small planet orbiting an ordinary star, in the suburbs of a magnificent galaxy. Our quest to understand the Milky Way is just beginning, and the adventure promises to reveal wonders beyond imagination. The Milky Way is a barred spiral galaxy, a vast rotating disk about 100,000 light-years across. Its central bulge is packed with old stars, while a bar of stars channels gas inward, fueling bursts of star formation and feeding the supermassive black hole at the core. Spiral arms, density waves, not solid structures, wind outward, glowing with young stars and nebulae. Our solar system sits in a minor spur, the Orion Cygnus arm, between the larger Sagittarius and Perseus arms. Surrounding the disk is a vast halo of ancient stars, globular clusters, and dark matter, the invisible glue holding the galaxy together. The Milky Way's structure is a record of billions of years of cosmic evolution. At the heart of the Milky Way lies Sagittarius A, a supermassive black hole about 4 million times the mass of our Sun. Hidden by clouds of gas and dust, its presence was revealed by the rapid orbits of nearby stars. In 2022, astronomers captured its first direct image, a glowing ring of superheated gas surrounding a dark shadow. Unlike the monsters of science fiction, Sagittarius A is mostly quiet, occasionally flaring as it feeds on stray material. Its immense gravity shapes the galaxy's core, warping space and time itself. Studying Sagittarius A offers a window into the extremes of physics and the evolution of galaxies. Our solar system resides in the Orion Spur, a quiet region between the Sagittarius and Perseus arms, about 26,000 light-years from the galactic center. This location shields us from the chaos of the major arms, providing stability for life to evolve. We orbit the Milky Way at 220 kilometers per second, taking about 250 million years to complete one galactic year. Since the Sun's birth, it's made this journey only about 18 times. Each orbit exposes us to new interstellar environments, subtly shaping Earth's history. The last time we were here, dinosaurs roamed the planet. Our position in the galaxy is both a refuge and a launch pad for cosmic exploration. The Milky Way's vastness puts our existence into perspective. The solar system is wrapped in the Heliosphere, a magnetic bubble created by the solar wind. This shield protects us from most cosmic rays and harmful radiation from the galaxy. The heliosphere's edge, the heliopause, marks the true boundary between our solar system and interstellar space. In 2012, Voyager 1 crossed this frontier, followed by Voyager 2 in 2018, humanity's first emissaries to the stars. These probes send back data from the turbulent boundary, revealing a dynamic interface between solar and interstellar winds. Carrying golden records, they will wander the galaxy for millions of years, silent ambassadors of Earth. Our reach now extends beyond the Sun's influence, into the great unknown. Our closest stellar neighbor is the Alpha Centauri system, just over 4 light-years away. A remarkable trio of stars that includes Proxima Centauri, the nearest to our Sun. This system is so close in cosmic terms that if we could travel at the speed of light, it would still take us over 4 years to reach it. Proxima Centauri hosts at least one Earth-sized planet in its habitable zone, making it a prime target in the search for life beyond our solar system. Scientists are especially interested in this world, as it could potentially harbor conditions suitable for life as we know it. Barnard's star, the second closest, is an ancient red dwarf with a super-Earth planet, moving rapidly across our sky. Its swift motion makes it a fascinating object for astronomers, who track its journey through the galaxy. Sirius, the brightest star visible from Earth, is a binary system, consisting of a hot, luminous star and a faint white dwarf companion. This dazzling pair has inspired myths and stories for thousands of years. These nearby systems reveal the incredible diversity of our stellar neighborhood. Multiple stars, planets, and remnants of stellar evolution, each with their own unique characteristics and histories. Most stars are part of multi-star systems, not solitary like our Sun. This means that planets in these systems may experience complex orbits and changing skies. The search for exoplanets around these neighbors continues, fueling dreams of interstellar travel and the hope of finding other worlds like our own. Our local neighborhood is a microcosm of the galaxy's variety, showcasing everything from massive blue stars to tiny, cool red dwarfs. Even the closest stars are distant, but they connect us to the wider cosmos, reminding us of our place in the universe. The night sky is full of stories waiting to be discovered, each star a chapter in the ongoing tale of our cosmic neighborhood. Some stars in the Milky Way are true giants, like UY Scuti, a red hypergiant so large it would engulf Jupiter's orbit. In Orion, the Hunter, we find Betelgeuse, a red supergiant nearing the end of its life, and the Orion Nebula, a stellar nursery where new stars are born. The Orion Nebula, just 2,300 light-years away, is the closest massive star-forming region, glowing with the light of newborn stars. Recent observations by the James Webb Space Telescope have revealed hundreds of rogue planets and intricate details within the nebula. These regions show us the life cycles of stars, from birth in nebulae to death in supernovae. The constellations are more than patterns. They're windows into the galaxy's ongoing story. Every bright star and glowing cloud is a chapter in the Milky Way's history. Our own origins are written in these cosmic landmarks. The Milky Way's stars belong to different generations, or populations, defined by age and chemical makeup. Population I stars, like our Sun, are young and metal-rich, found in the spiral arms, ideal for forming planets and life. Population II stars are ancient and metal-poor. residing in the halo and bulge, relics of the galaxy's early days. Globular clusters are dense collections of these old stars, offering clues to the Milky Way's formation. The first stars, population 3, were massive, short-lived, and made only of hydrogen and helium. Though never observed directly, their supernovae seeded the cosmos with heavy elements. Each generation builds on the last, enriching the galaxy and making worlds like ours possible. The story of stellar populations is the story of cosmic evolution. A century ago, we thought the Milky Way was the entire universe, a single island of stars adrift in a vast, dark sea. Edwin Hubble's discovery of galaxies beyond our own shattered that view, revealing a cosmos filled with billions of galaxies, each with its own mysteries and stories to tell. The Milky Way's history is one of growth and collision, forming stars, merging with smaller galaxies, and leaving streams of stars as evidence of these ancient encounters. 11 billion years ago, a major merger reshaped our galaxy, sparking waves of star formation and forever altering its structure. In the distant future, the Milky Way will collide with Andromeda, merging into a giant elliptical galaxy, Milkomeda, a transformation that will redefine our cosmic neighborhood. This cosmic dance will take billions of years, with stars mostly passing by each other unharmed, their vast distances keeping them safe even as galaxies merge. By then, our sun will be a red giant, and Earth's story will have ended, its legacy written in the dust and gas of the galaxy. The Milky Way's journey is far from over. It's a living, changing part of the universe, constantly evolving and shaping the cosmos around it. Our understanding continues to evolve, expanding our sense of wonder and possibility as we uncover new secrets and push the boundaries of knowledge. We are witnesses to a grand cosmic story, unfolding across billions of years, and our curiosity ensures that the story will never truly end.